All right, good morning, algebra. So today I wanted to show you guys how to graph an exponential function. It is a little bit different than what we've done so far as the graphs look different. The arithmetic you're going to be doing is a little bit different because you're going to be evaluating exponents other than a squared. So when you graph the quadratics, when you evaluated the quadratics, your biggest exponent was a 2. These are a little bit different. You're going to need to find the exponent key on your calculator. Is the one that kind of looks like a triangle without the bottom here. It should be on the left-hand side, about halfway up on the calculator. I don't have one in front of me right now, but that will allow you to evaluate any exponent on any base. So if I wanted to take like 2 to the 5th power, I'd hit 2, then my caret key, and then the 5th power, and then equals, and you're done. So these are going to be, you can multiply them out longhand if you want. You can set there in 2 times 2 times 2 times 2 times 2 and whatever. But I would encourage you to learn how to use your calculator, make yourself efficient at this so you don't have to do that. So the big change from what we've been doing to now is that your numbers are going to get a lot bigger, a lot faster. If you go through and evaluate this, 2 to the 0 power, that 0 is not a multiplier. The first time around when we evaluated these, several of you just multiplied the base and the exponent together. That's not how exponents work. These are not multipliers. I'll say it again. You are not multiplying these numbers together. So when I take 2 to the 0 power, by definition, that value is 1. Anything to the 0 power is 1. And then I go through and I'm going to evaluate my other exponents. 2 to the 1st power, 2. 2 to the 2nd power, text box isn't liking me, is 4. 2 to the 3rd power is 8. So I'm doubling this thing every time. And 2 to the 4th power is 16. So if you've studied science, you've probably heard about like cell division when the human embryo is conceived. So we start out as like a single cell egg, and then when it's fertilized, what happens is that egg kind of bunches together in the middle and pulls apart, and then that process happens again on each of the 2 cells. So we're doubling at the cellular level. We double every single time that happens. Now I don't know the time frame on that, but it's kind of neat to see how big something can become when it doubles like that. So I found this super short video, 30 seconds, and it's a population of fish, and it just shows what happens when these fish double. So initially, that means at the beginning there were 4 fish in this tank. Right now, every week the number of fish in this tank is going to double. So we start out with 4. After a week, we're going to have 8. And then the next week, there's going to be 16. And then the next week, there's going to be 32. You get the drift there. So, I mean, that doesn't seem all that great. But, I mean, after the first 4 or 5 doublings, it gets to be pretty massive. Now, imagine that on a cellular level. You know, we start out as these little teeny tiny specks, and then we split and double, split and double, split and double, split and double. And before you know it, you got a baby. It's kind of cool. Anyway, just trying to bring in a little bit of something else there. But back to this. So I have evaluated all of these. I'm going to go back and graph my points real quick. So when I go to graph these, it kind of looks like half of a parabola. I assure you the left-hand side of this thing does not do that. Evaluating negative exponents is a little bit outside of our scope in algebra. So I'm going to go back and draw my lines. So I'm going to go point to point to point. And again, kind of like we did with the quadratics, I want to stress that these are not angular shapes like this. They're not nice and sharp like that. They're curved. There's kind of an art to it almost when you draw them. Just in case you're curious, the left-hand side of this, what happens is it kind of comes back here and tapers off almost at 0. So these things start out super small, super small, super small, and then they just take off like a bottle rocket almost. All right, so next one, it's still the basic same evaluation. I've changed the base to 3 instead of 2, but I have added this -2 at the end. So you're still going to evaluate the exponential part, 3 to the 0, 3 to the 1, 3 to the 2, so on and so on and so on. And once you've done that, subtract 2. That's going to be your f of x value. So remember, anything to the 0 power, 3 to the 0 power is 1. Subtract 2. Now it's at -1. Okay, and we will get into like subtracting 2 here at the end. Pay attention to the graph and see if you can figure out what that -2 actually did to the graph. So go through and graph your points. Okay, so I've graphed the 3 points that I can, and if you notice these last 2 here, because it jumps up to 25 so fast and then it jumps up to 79, I don't have a graph nearly big enough to do that. So kind of like we did with the quadratics, just graph as best you can. If something jumps off the graph, so be it.